Yeah, we are live.
All right, thank you. We are back for our second workshop. So this is going to be a workshop giving an overview of AWS and specifically Bedrock. And so I'm going to pass it over to our next workshop host, Varsha from the AWS team. Varsha, feel free to take it away.
Sounds good. Thank you, Adam. So I'll be sharing my screen real quick. Cool. I think everyone should be able to see my screen now. So yeah, today, hope you were there with us in Denver last week. We kind of had our pre-hackathon first workshop, and then today will be kind of part 2 of that. And then we'll have Emile Baizel, who will give a do the workshop on Bedrock. Before we get to that part of today's workshop, I wanted to start off with our Biddle Battle Challenge from AWS. So once again, I'm Varsha, and I'm a Web3 blockchain solutions architect from AWS. And with that, we'll get started. So our hackathon challenge is Biddle with Bedrock. So basically, we want to challenge all of you to build with Bedrock. And we'll go more in depth about how you can do that and whatnot. However, it's our fully managed service where we have a whole bunch of foundational models that you can pick from, and we just want to challenge you to create a solution where you build on stacks, but then also incorporate Amazon Bedrock to your solutions. So our requirements are, pretty simple. We just want you to incorporate Amazon Bedrock into your solution and then demonstrate a real-world Bitcoin utility. With your solution, we want to keep it as broad as possible to kind of invoke you guys to be more creative with your solutions. And we're super excited to see what all of you come up with. This is a page with a whole bunch of QR codes to our documentation. So the first one is our Stacks Amazon blockchain node runners blueprint. And then we have several documentation links to Bedrock documentation. And then at the bottom, we have 2 GitHub repos, one with an example of a crypto AI agent built on Bedrock. And then the other link is to a whole bunch of Bedrock samples. That way you can kind of help you get started with creating your solution. Again, we want to kind of get you guys thinking and come up with various projects and solutions. However, these are some ideas that we put together for you to kind of come up with your own, or you're more than welcome to also use some of these example projects as well. So some suggestions we had were to use Bedrock to prevent people from making financial mistakes with stacks. And then we also want another suggestion that we had was to incorporate using Amazon Nova models, and then creating solutions where you're keeping up-to-date news about stacks by crawling related websites, and then also using our Bedrock data automation to parse multi-model objects. Another suggestion we had was to figure out a way to integrate Amazon Bedrock to a decentralized identity provider. And our judging criteria is, we just want to see you innovate and come up with original solutions. We'll be looking through your technical implementation. We want to see something that has real world applicability and a seamless user experience and design. It doesn't have to be perfect, but the last one is we want to see you integrate Amazon Bedrock into your solution some way. And we will be checking for whether or not you actually use Bedrock. So that's the judging criteria we have for our challenge. And now to the fun part, the prizes. So these are the prizes. As you may already be aware of, we're offering up to $50,000 in AWS Activate credits, and this is how we're distributing it. So as you may already be aware of, we have 4 tracks. These are our tracks: the Bitcoin 3.0 digital economy, real world ordinals or NFT usage, and tooling and infrastructure. So for the best solution that kind of fits in each one of these categories, you will receive 10K in AWS Activate credits. And then whoever has the best solution for the challenge will then also get a 10K worth of AWS Activate credits. There are a couple of disclaimers, though. To receive credits, winners must separately qualify for the AWS Activate program, and all AWS Activate credits are in USD and are subject to the AWS promotional credit terms and conditions. And also something to note is that if your startups aren't eligible for AWS Activate credits if they have previously received the same or a greater amount of credits. And in terms of the tracks and prizes, it doesn't matter if you kind of win one of these 4 tracks and you are the best solution that incorporated the Bedrock challenge. It's all going to be separate. So it's not like you can win one of the 4 tracks and then also win the challenge, and then you would, once you win, if you're a winner for any of the tracks or the challenge, if you're a winner for any of the tracks, you're automatically disqualified for the challenge. So the maximum amount of credits that you can win is 10K, regardless of how, regardless if you happen to have one of the best solutions for one of the tracks and incorporate the challenge. So so those are just in mind, but other than that, these are the prizes that we have for you. And with that said, that's all I had for the challenge. Super excited to see what everyone comes up with, and looking forward to mentor and judge. And with that, I will hand it over to our one of our solutions architects, also on my team, Emile Baizel. I guess I'll hand it over to you now.
Awesome. Thank you, Varsha. Do you mind? I think I'm getting feedback from your side. Awesome. Thank you. Thanks for presenting all of that. And hi, everyone. Emile Baizel, Senior Blockchain Architect at AWS. And Varsha mentioned a few ideas around things you could build for this hackathon. And what I would like to do here is present, is first of all, share my screen. And then I am going to talk about Amazon Bedrock and kind of focus on 3 distinct areas. And then I'm going to tie them all together at the end with a sample solution for that incorporates all of these. And the 3 areas are using Bedrock for LLM inference, using Bedrock for agents, building agents that use the LLM inference, and then using Bedrock for knowledge bases, which is for Retrieval Augmented Generation. And if you're not familiar with what that is, that's okay. I will talk about that too. So let's start over here. There we go. Okay, so when we think about generative AI at AWS, we think about it in a few different tiers. We think about at the very top, the applications that natively integrate generative AI, and we have a handful of those. And one of the ones that I use almost every day is Amazon Q Developer. It's a coding assistant that lives within VS Code and other IDEs. And we have other services too, like Q Business, Q and QuickSight. Those are probably not going to be relevant for the hackathon here, but I do want to point it out just to kind of help give you some ideas of how we think about generative AI. And then on the bottom tier is our infrastructure layer. And so our biggest product there is Amazon SageMaker. It's what developers and data scientists use to build, train, deploy machine learning models at scale. We also have our infrastructure, so GPUs from NVIDIA and other providers. We have our own silicon with Trainium and Inferentia chips. Again, not sure if that's going to be relevant to this hackathon, but just want to help set the context for Bedrock and AI in general at AWS. For the rest of the talk, I'm going to be focusing on that middle layer, which is Amazon Bedrock. And there are several features which we highlight there, and I'm going to get into all of those shortly. Cool. So Amazon Bedrock, first and foremost, is a fully managed service. So there's no infrastructure for you to spin up. There's no infrastructure for you to monitor, scale yourself. We handle all of that for you. So everything that I'm going to be talking about here is done via APIs and via the SDK. And it's a fully managed service that offers a choice of high-performing foundation models from leading AI companies. And that includes AI 21 Labs, Anthropic, Meta, Stability AI, and Amazon. And so with that, you get a broad set of capabilities to be able to really identify and experiment with different providers, looking at performance, looking at accuracy, looking at cost, and really being able to hone in on which model works best for your application. And while we do all of that, we aim to simplify the development of generative AI applications while maintaining privacy and security throughout the entire life cycle of your development, as well as your application once you ship that into production. Bedrock also includes fine-tuning and customizing your models with Retrieval Augmented Generation. I'll get into more details in that later. And also creating agents, which I'll get into later. And again, all of this can be done without writing any code. Of course, you can write code, especially if you want to get into more customization and things like that. But out of the box, you can go to the AWS console and build an end-to-end agent that uses any leading foundation model and have that running in an application in a short amount of time. Cool. Okay, so from speaking to hundreds and thousands of customers about generative AI, what we found is across all their different use cases, what really bubbles up to the top is being able to have choice across what foundation models and what providers they work with. And so from the beginning, we've offered a broad category of providers and models within each of the providers within Bedrock. And so I already mentioned some of them here. And at the late last year at AWS reInvent, we announced a few more models within Amazon. And those are our Nova models, which I'll touch on shortly. But we also have models from Meta, from Mistral, and from several other providers as well. And as I mentioned earlier, it's very easy to switch between these providers. It's basically just changing in your API call which what label you're using for the model, which model you want to use. I want to touch on two of the more popular models which we have, and this slide is slightly outdated now that Claude Sonnet 3.7 released less than a week ago at this point. But I'm keeping it here because over the past year or so, we've seen a lot of customers build with 3.5 Sonnet because they found it's been a great balance of accuracy, latency, and cost. And Anthropic also offers Haiku, Sonnet, and Opus for different use cases. So Sonnet's always a great one to experiment with. And then the Amazon Nova Foundation models, which have been out for just a few months at this point, offer a broad range of capabilities. So if we start on the left side, the four on the left are what we call the understanding models. And these are the ones that many of you who use generative AI day to day are most likely working with these understanding models. And on the right, we have our creative content generation models. So we've got Canvas, which generates images, and then you've got Real, which generates video. So if we focus on the understanding models, if you're building a chatbot or something that requires low latency text-to-text inference, Nova Micro could be a really good fit. It's low latency, it's very low cost, and this could be a great fit for that. It's not multimodal, so it only supports text input. Now, as you move on to the right and you're looking at Amazon Nova Lite, that's our lowest cost multimodal model that is also designed for low latency applications. And then if you move over one more to Nova Pro, that's again multimodal with more intelligence than the prior two as well. So again, it's very easy to experiment between trying out all these different models here. And I think it would be really neat to see some projects using some of the creative content generation models, as those are fairly new as well. So cool. DeepSeek R1, just a quick slide if you are building with that. That is also available via the AWS Marketplace to run that on AWS. Okay, so that is the first of the three categories. That is LLM inference. The takeaway there is you have a wide range of providers that you can work from, and it's very easy to switch and experiment between different ones there. Okay, so let's move on and let's talk about agents. I was just at ETH Denver last week, and agents is pretty much what everyone was talking about, so it seems like a great topic to include here. Okay, so as we talked about prior, we have a broad choice of foundation models, and when you're building an agent, you can build across any of those or using any of those foundation models. And we provide additional features such as memory for the agent, so you can have recall across different interactions with the user. We have knowledge bases for retrieval augmented generation. We've got guardrails for making sure that the users are protected and also not trying to ask questions that they shouldn't be asking. And all of those are available as part of inference. So even if you're not using agents, but they're also part of agents as well, agentic workflows. And then we also have tools and action groups. And if you're familiar with AWS Lambda functions, the serverless functions, that's essentially how you can think of action groups here. So when you have a Bedrock agent and it's tasked with executing a task, it can accomplish that via its action groups. And the action groups can be one-to-many different functions. And those functions are AWS Lambda functions there. Again, Lambda is serverless, agents are serverless, Bedrock is serverless. So there's no underlying infrastructure for you to maintain. It just scales as you scale, and you only pay for the resources that you use at any given time. And then tracing, debugging, and observability is something that's built into agents. So as you're trying to figure out why your agent orchestration isn't working, you can actually go in and see what the agent was thinking it was trying to do and where it may have been tripped up, or maybe it didn't have the right permissions and you need to update your IAM policy or something like that. So we try really hard to make it very transparent what the agent is doing so that you can build more quickly and have an agent working in a shorter amount of time there. And the last thing is also at re:Invent last year, we announced multi-agent collaboration. And what this allows you to do is make agents aware of other agents, and specifically in a hierarchical form where you have what we call a supervisor agent, which would likely be the agent that the user is interacting with. And that agent is aware of all these other agents, which are known as collaborator agents. So you have a supervisor agent that delegates or can delegate to collaborator agents. And the benefit of that is you can really start specializing these collaborator agents to be really good at what they're aimed at doing, right? So in an example I'll be showing a bit later on, we have an agent that's really good at retrieving historic Bitcoin data from the blockchain. And so anytime we need to get that data, we can just delegate to that agent. And we don't have to add any of that additional knowledge or instructions to the overall agent there. Again, that can be a really powerful setup in the right application, having multiple agents working together there. So real quickly, how to get started with agents. You select your foundation model, and everything I'm describing here, again, is click through in the AWS console. You go to Bedrock, go to agents, create agent, and then you select your foundation model, give it some basic instructions, like you are a SQL developer, you are an application builder, whatever your instruction is. Select your relevant data sources. This is for Retrieval Augmented Generation. And then you specify what the available actions are. And those are the Lambda functions, essentially, which the agent's going to do. And again, if there's a lot to grasp here at the end, I'm going to tie everything which I'm covering into one solution architecture diagram, and you'll see kind of how all these pieces fit together there. If you are interested in multi-agent collaboration, we have a GitHub repo that has some examples there. Building a marketing strategy, chatting with a mortgage company, planning a trip, other things like that, if that's something that is of interest. And we recently integrated into Eliza OS. So if any of you are interested in building agents with Eliza OS, you can use Bedrock as your LLM inference provider with any of the providers which I mentioned earlier in the talk there. Okay. So now we've covered two of the three. We've covered inference and we've covered agents. And so the third thing I'm going to cover is knowledge bases for retrieval augmented generation. If you're not familiar with RAG, a way I like to think about it is when a large language model is created, it's essentially, its knowledge is capped at that moment in time where it was created. Right. So anything that was created as of January 1st of this year wouldn't know anything that's happened since January 1st. Right. And so retrieval augmented generation was created as a way to provide additional context to the large language model that it can use when it's generating its response. And typically this can be more current events. So you can pipe in news or other information like that, or it can be proprietary data. So information that will never be available to a large language model because it's behind your own AWS account in a database or something else like that. But since you're owning all of that workflow, you can bring that data and provide it to the LLM without exposing it to anyone else. So there's a couple of different use cases there. And so Bedrock knowledge bases makes orchestrating this end-to-end workflow very, very easy. Again, you can do this directly from the AWS console. You go in, create a knowledge base, create your data source, and a couple of data source examples are you can have a web crawler. So you can define a news website, for example. Maybe there's a website that focuses specifically on Bitcoin and on stacks or that general space, and you want to bring that into your agent. So you can define a web crawler and say, crawl that site every 5 minutes or something. And then what it does is it'll bring that data in and put that into a vector store for your agent. And then your agent will now have that additional context whenever it's making an inference, whenever it's processing an inference request. You can also have a data store of just an S3 bucket. So anytime anything gets added to that S3 bucket, whether it's your documentation or images or anything else, it can be multimodal. It'll parse all of that and again, put that into a vector store. And now that's available for your users, for your agent. And what I saw several projects doing at ETH Denver was that second approach where they really want to simplify the onboarding for users, because as many of you probably know, it can be a bit difficult for new users to start using cryptocurrency and wallets and having to understand all of these things. And so the approach that they were taking is adding their documentation and some sort of beginning 101 informational documentation to an S3 bucket that automatically then becomes part of the agent's knowledge repository where it can start answering questions about that as well. So how this works is these are all numbered here at the top, and I'll just kind of go through that. A user makes a request, an inference request, and if it makes sense to go to the knowledge base, the Bedrock will query the knowledge base with the user's prompt, which will then retrieve additional context, additional data and information. And then if we go to number 4, that is an augmented prompt. And so we then have the user's query along with the additional context, which we retrieved from the knowledge base. Then in step 5, we work with any model again, which we talked about in the very first part. It can be any of the providers, any of the models, and then we get our answer. And again, all of this can be done through the console without any code required. You can get into the code if you want to become more, get more specific about how the data is stored in your data store. And a lot of times, what I've seen customers do that do end up doing that is really fine-tuning, not LLM fine-tuning, but fine-tuning the searching capability for the knowledge base, being able to add semantic search besides just vector embedding search. Anyway, if any of that sounds interesting or sounds like something you will need some more info on, please reach out. We'd be happy to chat more about that. We support a wide range of vector stores for knowledge bases. By default, we set up an Amazon OpenSearch serverless data store, but we support PG Vector with Postgres, Pinecone, and a few other ones as well. I'm going to skip over this real quick. Just a couple other things that we have around managing data with Bedrock data automation, and then also with GraphRag. So when I talked about being able to connect multiple data sources, with GraphRag, you can identify an entity across all of these different data sources, which allows you to build a richer picture of an entity. And that entity can be an individual. It can be anything essentially that has some information about it in multiple data stores. And this is built on top of Amazon Neptune, which is a graph database. But all of that is abstracted from you, and you just work with this via the APIs. Okay, so that's all 3 things from Bedrock. We had the inference, we had agents, and we had knowledge bases. I'm going to touch on one more thing here, just because I think it could be relevant. This is not part of Bedrock, but it is part of AWS. It's our AWS public blockchain data. And these are publicly available free data sets from 7 different blockchain networks. And we're actively working to add many more to this set. Most relevant to this hackathon will be the Bitcoin one. And so with this data set, you have the ability to query the latest wallet balances, block information, transaction information, all from your AWS, from your application running in AWS, and accessing that data is free. So I'll just put that there in case you are looking to access historic Bitcoin data within your application. Cool. So I talked about a lot of things, and I included this here because I think sometimes, at least for me, it helps to see how everything fits in the context of an overall application. So everything which I've touched on in my presentation is within this diagram here. You'll see a QR code and a link at the bottom. This is all available on GitHub, and there's a one-click deploy that takes 10 to 15 minutes with no user input really required. So you can get this application running within 10, 15 minutes inside your AWS account itself. And if you want to do that, just follow that QR code or that link down there. So starting at the very left here, what we have is the supervisor agent, which if you recall, I was talking about the multi-agent orchestration. And so we have the user interfaces with this supervisor agent to ask it, hey, what's the latest news that's trending about blockchain? And so the supervisor agent goes up to the very top because it knows it has a knowledge base. We've told it that it has this knowledge base that is all about the latest blockchain news. And so what we have up top is a knowledge base that we've got a web crawler that goes out to a blockchain news website every minute, downloads that data, scrapes it, creates, passes it into Amazon Titan embeddings, which is our large language model for creating embeddings. And that gets put into an OpenSearch serverless vector store. And so now when the user asks the question, that goes up to the knowledge base and it returns its answer there. So that's an example of how to use knowledge bases. Now, if we want to get some historic data, so let's say we want to understand like how many transactions were happening on Bitcoin yesterday compared to a year ago. Like, are we seeing similar patterns or something else like that? So that's a great use of the public data sets, which I was just talking about. And so what we've created here, which is the blue circle right in the middle, number 3. And there we have a collaborator agent. So this is, again, a multi-orchestration setup here, where you have the supervisor agent now delegating, because we've told it for any questions about historic data, go to the collaborator agent. And the collaborator agent has been tuned to really focus in on how to query this data coming out of there. So the agent, the output of step 3 is a SQL statement. And that SQL statement then gets put into a Lambda function, which is right there in the middle of the screen, which then executes that on Athena, Amazon Athena, to get the data that you need there. So what we have there is an example of multi-agent orchestration. Now, if we go to that third row, so basically the second Lambda function in the 3 there, what we have here is getting real-time token asset pricing. And so we've plugged into CoinGecko here. So you need an API key when you're deploying the application if you want to use this. And this handles responses to questions like, what is the current price of Bitcoin, or any other asset like that. And so that's an example of just attaching an action group directly to the agent and then having it go and retrieve something via an API call. And the last thing is how we send transactions to the network. And so in this bottom one, which is number 4, we would reach here with a prompt such as send 0.001 Bitcoin to this address. And so we have a wallet management action group. And what we've done is we've attached a KMS key. So KMS is our key management service. And natively, it supports the elliptic curve that is used by Bitcoin. And so what that allows us to do is create a wallet, essentially. Create a wallet, so the private key remains within KMS. You can never export it. There's no way to export it. And we get the public key for that, which is our wallet address. And now we can use that wallet address to receive funds and to check our balance and everything else like that. But if we want to send funds, what we do is we tell the crypto AI supervisor agent, number 1, hey, I want to send these funds. That goes to the wallet management Lambda function, which constructs the transaction as it would need to be for Bitcoin or whichever network it's working with. And it would send that payload to KMS. KMS would sign it with that private key that only it can use, return that to the Lambda function, which then sends it via JSON RPC to the RPC endpoint. And so what we have here is a way to query real-time data, a way to query pricing data, historic data, and then how to send transactions. So there's a lot there. But again, if any of this seems like it might be something you might want to use, I strongly recommend looking at that repo and just seeing if you can borrow any certain parts of that. And again, we're always here to answer any questions. And so with that, I will say go build. I think Varsha might have shared some of these, but I'll share them again. Great place to start is on the left. You've got the developer center, very developer focused on building with Bedrock. In the middle, if you prefer watching YouTube videos, you can see step-by-step tutorials. And then highly recommend that GitHub repo on the right. There's everything that I talked about in this presentation. There's at least one example of how to build that. We have lots and lots and lots of code samples around that. And with that, I am going to pause.
Perfect. Thanks, Emile. Thanks for that overview. Thanks for that workshop. And then also thanks to Varsha for kicking us off with an overview of the challenge as well. So if you have any questions with that, you can also comment in the DoraHacks page, or you can join our Telegram group. We have a dedicated AWS channel in the Telegram group for Biddle Battle. Varsha, Emile, and some of the other team from AWS Bedrock will be in there to answer any questions that you might have. So thanks to you both, and we'll see everybody else in Telegram and also into the next workshop.
Cool. Thank you, Adam. Thanks, everyone.
Thank you.